Hello, good afternoon. Hello, Bipul sir.
Hi, right, sir. I'm here. Good afternoon.
Yes, sir. Yes, sir. Good afternoon, sir. Very good afternoon to all the participants. Uh, Today, this is the third session of day 2 AICTE-ISTE sponsored refresher program on machine learning and pattern recognition. Now, today, Bipul sir is with us to continue the session. So, I am handovering the session to Bipul sir. Sir, Bipul sir, please continue the session.
Right, sir. Okay. Hello, everyone. Very good afternoon. So today's session, the agenda of today's session is about the classification things, right? So without wasting much time, let's start the part. So in the last class, what we had discussed, right? Today we are facing network. Am I? My voice is clear or not? My voice is clear, right?
Yes, sir. Yes, sir.
Okay. Okay. So someone else is facing. Anyway. In last class we had discussed about the data pre-processing and the need of data pre-processing and all. Today we will discuss the algorithmic part. Algorithmic part of what? Algorithmic part of classification first, and then we will discuss the regression and all. Okay. So before starting the classification, we should know what a classification is. You know, when a classification is required, right? Look, machine learning is basically of two types, right? All of us are knowing. Okay, supervised and unsupervised. Okay, one more is there, reinforcement. Okay, basically I should say three types, not two types, right? So generally machine learning conducted in three different ways: supervised, unsupervised, and reinforcement, right? In supervised, we are having again two types, right? One is classification. That means we create a classification based model. Okay, and second, we create a regression based model, right? Regression based machine learning model. Okay. Classification based model means what? The categorical model for categorical prediction. Okay, categorical model for what? For categorical prediction. Okay, that is a classification based model. Regression based model means what? The model for continuous value prediction. Okay, continuous value prediction. Okay, that is your regression based model. Right. Example, if you have to consider, how can we consider the example? You know, for example, if I have to make a model, for example, if I have to make a model for weather forecasting. Okay, weather forecasting. So weather forecasting, what can be there? Okay, it can be like, you know, it can be like the weather is sunny, the weather can be like cloudy, the weather can be rainy. Okay, I have to make a model for any kind of a disease prediction. Okay, disease prediction. Okay, so disease prediction means what? That particular disease is there or it is not there, yes or no, true or false, isn't it? I have to make a prediction for sales, profit or loss. Correct. That means in next month or in current month, I will earn profit or I will earn loss. Okay, that is what I have to make. Okay, I have to make a prediction about the stock market, that is, it is going to be bullish, okay, or bearish. Okay, so it is what? These are different things, but here the categories are fixed. Like you can see in the first there are three categories, in the second there are two categories, in third two categories, then we are having again two categories. Okay, so number of categories are what? Number of categories are basically fixed. Okay, out of these categories, okay, any one category will be predicted, right? So this is the case, okay, where machine learning is considered as, or the machine model is considered as the classification based model. Okay, on the another ground, if we talk about regression, here we predict the continuous value. Okay, continuous value means what? Like kind of, you know, like you have to predict the sales value. So sales value can be anything from 0 to infinity, isn't it? Sales value can be anything, that is from 0 to infinity. Okay, a stock price value. Okay, a stock price can be anything, right? Population growth value, population growth prediction. Okay, income prediction. Okay, so these many things, okay, that will be called as, considered as a regression. In detail, the regression we'll see in next class. Today it is a day of classification. Correct. So we have to discover classification more. So to deal with classification, actually, we need to learn, or we need to know some algorithms. Okay. So I'll discuss some algorithms over here. Thereafter, practical part will be considered. Correct. So let's see quickly. Let me tell you some algorithms. Okay. So there are certain algorithms. Okay, like logistic regression. Okay. The name is logistic regression, but it is actually a algorithm for classification based model. Okay, it is a model. It is an algorithm for classification based model, right? Then what we are having? We are having something called decision tree classifier. Decision tree classifier. Okay, we are having knn, k nearest neighbors. Okay, SVM. Okay, random forest. There are n number of algorithms are there, 28 to 30 algorithms that are there, right? So it is not like all the algorithm we need to know. Okay, if you are knowing 5 to 6 algorithms, then we can solve 90% of the problem. Okay, it can be easily solved. It is not like that we have to go through all the algorithms. That is not required at all, right? At least 7 to 8 algorithms you are knowing, then it's more than enough. Okay, but if you are doing some research or something like that, and you want to know each and every algorithm, so that is another thing. But as for development purpose, we can just go with maximum 5 or 7 algorithms we try, and thereafter out of those 5 or 7 we just decide one of them, okay, based upon their performance, right? So what exactly logistic regression is? Okay, so logistic regression is an algorithm, okay, that is used for classification based problem. Okay, logistic regression, how it works? Look here, the name is over here regression. That means it initiates from the concept of regression. Okay, but it is used for the classification problem. Okay, it generated or it initiated, it is created with the concept of regression. Okay, but it is used for.
Sir, we can't see the screen.
You can't see the screen. Is my screen is not visible?
No, not at all.
For anyone, it is not visible. I had shared it at the beginning only.
The PPT not visible.
Visible, sir. It is showing Cisco page.
My just a minute. I had shared it. Why it is not visible?
Haven't
Not
shared, I
visible,
guess.
sir.
Is it showing paint screen now?
No, nothing.
No, sir.
Cisco's WebEx.
Just a minute. Wait. Now, is it showing? I guess it is visual now, right?
No, still we can't see anything.
Paint screen is visible, sir.
Right?
Paint is visible.
Yeah,
on screen.
right. I opened the paint. And so it is visible now for some of the people. Is it visible for everyone? Okay. Actually, this I had written so many things over here. I was thinking like it is visible, and I was explaining so many things by writing over here. Anyway, let me explain again. No, not let me explain, because those things are just the basic thing that you must be knowing. That is just a startup. Okay. So what we were discussing about the logistic regression, right? So logistic regression is a kind of algorithm that is used to make a predictions related to in a categorical way. Okay. So how it is used, since the name is logistic regression, that is one thing is clear. It emerges from the concept of regression. Okay. It emerges out from the concept of regression. So somehow regression is related to it. Okay. But it will be used for classification purpose. How? Let's see. Okay. For example, just consider a case. Okay, where the data is distributed like this. That means it is your x, it is your y. Okay, x is what? X is you consider as a feature. Okay, and y is your label. Correct. That means x is what? Independent variable. Independent variable. It is what? Dependent variable. That means y is depending upon whom? X. Correct. If it is depending upon x, then we can just plot it like this. Okay, some plotting we are doing, any some kind of according to some values, right? Now the thing is, if this is a plot, correct? These are the plots we are having, right? Now what we need a kind of a model that can use some value of x in future, okay, like this is a value of x, and can make a prediction for y for this value of x, okay, and can make a prediction of y for this value of x, correct? We need a model like that. Then the question is, how can I build a model for that? Okay, that is the main thing, right? So obviously to build a model for that, it is not possible that we can generate a reference line like this, otherwise my model will be overfitted. Okay, it is not possible. Okay, this kind of situation we can't create, correct? So what we prefer a best fit line that will pass through the data. Okay, let me use some other color. So we will prefer a best fit line that will pass through the data, okay, and that can best represent the data, isn't it? What we prefer? We prefer a best fit line that will pass through the data and that can best represent the data. Now question is how we can figure out this best fit line, correct? So to figure out best fit line, actually what I mean, different lines will be considered. Okay, suppose different lines are getting considered. This is one line, okay, okay, this is your one line, this is another line, okay, this is some other line, this is some other line, okay, like n number of lines are possible, right? There is no limit within this coordinate how many lines are possible, you can't count even, right? But machine can count. But when machine can count, a machine can calculate very easily all the lines, right? Now what will happen, all of these lines are there, all of these lines will have certain properties, right? Properties are what? All the lines in a linear line will be defined by a linear equation like b naught plus b1x, okay? All the lines will be defined by some equation, linear equation, isn't it? Now what will happen, suppose this is line 1, this is line 2, this is line 3, this is line 4, this is line 5, okay? Suppose b1 b naught, I'm just considering over here, b1 b naught is equal to 1 and b1 is equal to 2, okay? And because of b naught and b1 equal to 2, what am I getting? I am getting this thing, this line 2, okay, or line 1, okay, this is line 1, correct? So in that case, y hat, sorry, hat should be at the top. Y hat for line 1 is equal to what? Will be equal to b naught x plus, sorry, b naught plus b1x. This will be equal to what? This will be b naught is what? 1 plus 2x, right? This will be what? This will be your y1 hat. Okay, now what will happen? From this line, all the points will calculate their distance, all the existing points, correct? Like this point, this point, this point, okay, all the points will calculate their distance, okay? How much the distance are there? Actually it will be a perpendicular distance, it should be like this, right? So the distance will be calculated like that, okay? Now how it will be calculated looks, it will be calculated like this, okay? For every particular point, right, for every particular point there is a value of y, isn't it? Suppose the value of y is 5, okay, value of y is 5, okay? Suppose the value of x is 3, okay? So for x the value of y is 5, I'm just considering it, okay? Then for x the value of y hat will be what? 1 plus 2 into 5, that will be equal to 11. So what is the distance? Y minus y hat, this is equal to 11, right? So it is a distance, right? Now what will happen, line will actually over a average distance will be calculated for all the points, okay? Average distance will be considered for all the points, right? But I'm considering only one point, hope you understand, okay? It is not like single point will not be considered anytime. That means distance will be calculated from all the points and this distance will be considered as an average distance, not a single distance, right? Now what happened, this value will tune itself, okay? b naught and b1 will tune, okay? So if b naught or b1 will tune itself, that means you are changing the slope and intercept, okay? And if we are changing the slope and intercept, that means we are changing the orientation of line. That means now line shifted from 1 to 2, okay? When line shifted from 1 to 2, again distances will be calculated, okay, like this, a new distance, okay, average distance. Suppose the new distance that is coming, y minus y hat 2 is equal to 9, okay? That means the distance orientation, the error decreases. So if the error decreases, the line will keep changing in that direction only. The complete gradient descent I will explain in next class, right? So in this class, I am just giving a quick brief. It means from here to here, the distance or error decreases. That means line will keep moving, or you can say the optimization will take place in that direction only. Optimization will take place in that direction only, continuously. Okay. It will touches a point where it is having some error, like suppose y minus y hat 3 is equal to something like 5. Okay, for all the value, right? And then again it starts moving from this direction, but when it starts in this direction, the error start increasing. Okay, the error starts increases, like it again start increasing, right? So if it started increasing again, in that case algorithm will figure out, no, this is the best line and we have to consider this line. Okay, and this line, which is at a minimum possible distance from all the given points, minimum possible average distance from all the points, will be considered a best fit line. Okay, and how it basically figure out this thing through gradient descent and all that, I will explain mathematically. I'll explain, and we will implement that also, okay, in the next class. Today we have to consider about the classification. That's why I'm just giving a brief. Okay, so that's how your algorithm will figure out what best fit line. Okay, so this is a concept of regression. That means now what happened, whenever the prediction will require to be made, it will be made like that. Okay, it is your x, there will be a perpendicular from x to this, and this is your predicted value. Okay, this is a concept of regression, right? That all the regression points, all the points over this line will be considered as a predicted value. Okay, for different x value, for different x value, it will be considered as a predicted value. Correct. For linear, okay, for non-linear it can be like this or something like this, that is another thing, but for linear this can be considered as a predicted value. Clear? And if this is considered as a predicted value, okay, this can be used further also. Okay, but this is a concept of regression. What happens if we are going with classification? Then how can we use this concept? Let's see. Okay, to use the same concept for classification, logistic regression was proposed, or the concept of logistic regression came. Okay, if I have to make a, okay, let's see. Okay, just a minute. Okay. So what we can do, suppose you are having a plot, y plot and x plot. Okay, but in logistic regression, you know, we are having only one thing, either 1 or 0. There is nothing like anything like you know, like if you have a classification based model, we are making a classification based model, then we will, that model will only predict either 1 or 0, isn't it? Like true or false. Correct. So if true or false it is predicting, that means for certain value of x, these will be the value. Sorry, I just made it wrong. It should be 1, right? It should be 0. Okay, so for certain value of x, okay, there will be y. So I'm just representing this thing like this, like suppose different value of x, we are having a y like this. Okay, for certain value of x, there will be some 1 also. Okay, there will be some 1 also, right? Now what will happen if we are trying to make you know, linear line, right? Then what will happen? There will be a big challenge. Okay, it can be like this. Just suppose this is maximum, these are more in number, these are less in number, right? So in the continuation of calculating a minimum distance line, it can be something like this. Okay, anything like this, right? So in that case, what will happen? The situation is not too good, right? This is a line whose equation is what? B0 plus B1x. Okay, that means if I have to make a prediction for this particular point, okay, so it is going to be, or I have to make a prediction for this particular point, it is going to be something like anywhere over here. Okay, and if there is something like over here, okay, it is going to be over here. Okay, it is going to be predicted point over here, and if anything is x value is over here, okay, it is going to be some negative point also. Okay, some negative prediction will also come, right? That means if the same concept I will use for this particular situation, the thing will not go as usual. Okay, what will happen? We will get the value from negative infinity to positive infinity, anything. That is the one challenge. Second, it is very tough to define a threshold value or something, or figure out the minimum possible error. Okay, it is very difficult to figure out the minimum possible error or the best fit line, because from where because these points are in maximum, these are in minimum, then again there will be a challenge and all, right? And how can we calculate the minimum distance? Correct. So that's why it is basically introduced as a logistic regression. What is logistic regression exactly? Look here. Okay, suppose you are having a line over here, okay, like this. Correct. Now the equation of line is what? The equation of line is b0 plus b1x. Okay, that means, just a minute, y is equal to b0 plus b1x. Correct. So this line is having a no limitation. It can go from negative infinity to positive infinity anywhere in this world. Correct. Now I want to limit it. Right? If I want to limit it, then what I will do? I will just make a small change. I will just use the exponential value of it. Expy is equal to exp b0 plus, and exponentials are always positive, right? So that means it gets limited now. It can't cross in the negative direction. It will be always positive or zero. Okay, from where it just turned into zero. Correct. It can't go negative direction. So on this side it is limited, but I have to limit on another side also. Another side it is going like from infinity, like anywhere it is going, right? So I have to limit that. So for limiting that, what we can do? So suppose I have to limit 5. So what I can do? I can divide 5 by 6, or I can also write this thing as 5 upon 5 plus 1. Okay, then obviously it will never cross 1. Okay, it will never cross 1, right? Same thing we'll do over here. What we will do? We will make the equation like this. E of y upon e of y plus 1 is equal to e of b0 plus b1x upon e of b0 plus b1x plus 1. Enough? Right. Now what happened? The output will never cross 1, right? It will be whatever value you are putting in b0 and b1, like whatever, it will always be like this. Okay, it will maximum will be anyhow, if it touches 1, it will be anyway, it will be always less than 1, but anyhow if it touches 1 also, so that will be the maximum, okay, by somehow, but it will be always less than 1, 0 0.9, 0 0.99, whatever it can be, but it will be always less than 1, right? So that means on both the side it gets limited. Okay, so once this is done, so this equation is finalized, that this is the equation that needs to be used for logistic regression. Okay, unlike linear regression, we can't use over here the linear regression equation. So what we have to use? We have to use P is equal to E b0 plus b1x, that is your equation of linear line, upon E b0 plus b1x plus 1. Now you can divide numerator and denominator, okay, numerator and denominator both with the same value, E b0 plus b1x. So what will be the value? 1 upon 1 plus E minus b0 plus b1x. It is your final what? Logistic regression equation. Okay, it is your final logistic regression equation. That means what? For each value of x, now using this equation, your model will learn. Okay, using this equation, what will happen? Your model will learn, and will try to figure out b0 and b1 at minimum possible error. Right? That means our model, our machine learning model will do what? Our machine learning model will learn, okay, in such a way to figure out what? To figure out b0 and b1 at minimum possible error. That means it will work like this. I will tell you how it will work. Look here. Suppose the first value, it is a supervised learning, right? So for supervised learning, there will be x and there will be y. Okay. Suppose x value is 3, 5, 3, 5, 7, 2, 1. Correct. For this y value is 0. This is y value is also suppose 0 or 1. Okay. For this y value is 1. For this y value is 0. For this y value is 0. This is just an example. Okay. For some x, for some feature, okay, it is 0. For some feature, it is 1. Okay. Now we have to make a prediction for a value, suppose 4. What can be the y value for 4? So for making a prediction for 4, what can be the y value for 4? We have to train it, right? We have to train it. So for training, what we will do? We will start doing the things like this. Okay. We will do what? We will calculate probability of output for each one of them. Like 1 p is equal to, or p1 is equal to 1 upon 1 plus e minus b0 plus b1x. Correct. So that means what? X value is what? X value is 3. Correct. So 3 will come over here. Okay. 3 will come over here. You have to assume some value of b0 and b1. So just assume a value of b0 as 1 and b1 is also 1. So it will be what? 1 plus 1 into 3, that is 1 plus 3. Okay. For p2 is it will be what? 1 upon 1 plus e minus 1 plus 5. Okay. The same way all p1, p2, p3, p4, p5 all will be calculated. Okay. Now suppose p1 came as 0.7, p2 came as 0.6, p3 came as 0. Suppose something like anything like 0.5. Okay. P4 came 0.4. Okay. P5 came 0.6 or 0. Suppose 8, anything like that. Right. This is what I'm getting. Right. Then how error will be calculated? Error will be calculated like this. For the first one label is what? 0. So error is what? 0 minus 0.7. For second one it is 1. So 1 minus 0.6. For the third one it is 1. So 1 minus 0.5. Okay. For the fourth one it is 0. That means 0 minus 0.4. Now for the fifth one it is again 0. That means 0 minus 0.8. Okay. And then the mode of it, because negative positive will be there. So remove the effect of negativity. Okay. So it is what? 0.7. This is what? 1 minus 0.6, 0.4. This is what? 1 minus 0.5, 0.5. This is what? 0 minus 0.4, 0.4. This is what? 0 minus 0.8. Correct. Then calculate the average of it. Okay. What will be the average? 4, 4, 8, 8, 8, 16, 16, 24, 24, 28, right? That means 2.8 divided by 5. This will be equal to what? 0.56, if I'm not wrong. Okay. So it is the average error of the model. Okay. It is the average error of the model if this is a situation that I am getting. Okay. If this is a situation I am getting, then it is the average error. If it is the average error, that means my algorithm needs to tune the value of b1 and b0. Okay. My algorithm will tune the value of b1 and b0 and again train it. Okay. Sorry, again tune the value of b1 and b0, again use the value of x. Okay. Different value of x. Correct. The p1, p2, p3, p4, p5 will be calculated. Again the difference will be calculated from it. Okay. And again it will work upon to minimize the error. And you know, when it will work in this way, error will only be minimized when this value will minimized. Okay. 1 minus 0.6. Okay. How this will minimize? It will minimized when this 0.6 prediction will move towards 1. Okay. And when this value will be minimized, and how it will be minimized? It will be minimized only if 0.7 will move towards 0. Correct. This will be minimized. How it will be minimized? If it will move towards 1. Okay. It will be minimized. How it will be minimized? If it will move towards 0. And it will be if it will move towards 0. Okay. That means with the help of this particular error calculations, okay, the points, okay, the final prediction, okay, the final prediction always try to move towards their actual label. Since it is a supervised learning, right? That's why labels are helping them. Okay, because you know in supervised learning labels only help a model to get learned. Okay, labels will help them to learn. So here the labels are already there. Labels are fixed. Okay, so labels are helping them to calculate the error, and when the errors are configured, again algorithm are going back, again algorithm is moving back, tuning the value of these parameters, and when these parameters are getting tuned, okay, again errors are calculated by calculating a difference, okay, and this will continue again and again till the time minimum error achieved, okay. So that means if we consider this situation, that means what? That means there will be a multiple reference lines will be created. That means what? It will be like this, okay. Suppose it is a initial value, and this is the initial value, okay. Suppose it started randomly from anywhere like this, okay. Thereafter it will start calculating the error and try to fixing the error, right? So it will keep changing, okay. The orientations will keep changing like this continuously, okay, and finally one curve will fix itself, okay. Out of so many curves, one curve will fix itself with minimum possible error, okay. There will be a curve fix itself with minimum possible error, correct, and it will have a threshold value as well, okay. That means below that threshold value all are zero. That means whatever the prediction that will come below threshold value, all will be zero, and excuse me, and above that threshold value all will be whom? 1, okay. So that's how your logistic regression works to make a prediction between 0 and 1, right? Please let me know, am I clear? Okay, how what is the logic behind tuning this particular thing? Don't worry about it, I will come into detail of it, okay. As of now, just consider it will tune in the direction to minimize the error. It will just tune in the direction to minimize the error. The complete mathematical process I will cover up, okay, in the next class, okay. As of now, I'm just giving a small brief. So is the logistic regression equation is clear how it works? If you see any kind of just a minute. Is it, okay, fine. If you search anytime logistic regression equation, right, you will see the same thing over here, okay. You can see over here the lot many, it is the things you can see your equation something like this. Gone? Just give me 1 minute. Someone is at the door. Okay, I'm sorry, like someone came at the door from society. Anyway, so what we are having this thing, right? Equations, you can see like how it works, right? How the linearity has been break down, okay? From the linear equation, the linearity broke down to get a logistic regression equation, okay? So lot many figures and things you can see that you understood, that you can use for understanding, right? So same thing is given over here, right? Now next move for the next thing. Okay, so it is one of the simple algorithm that is used for the things. Okay, next what we are having multiple algorithms actually, right? So one more algorithm let me cover, that is known as decision tree classifier. This is very interesting algorithm actually, decision tree classifier. Okay, decision tree classifier, right? It is very interesting algorithm actually, right? So how it works, right? So it works by forming a tree shape structure. Okay, tree shape structure means what? For example, you are having, let's take one more example. Okay, you are having a situation like this, correct? Like suppose we are having a data of students, right? And like some students pass the exam, some students fails the exam, right? So you are having a data like this, assignment, like how many assignment one person completed and what is the attendance of a person and what is the result of that person. Okay, so suppose total assignment is 15, attendance for a particular person is 30 and result is fail or pass. Okay, so suppose out of 15 assignment, the number of assignment completed by a guy, suppose it's like 12, 13, 9, 10, 8, 15, and 6, right? And the attendance is what? Out of 30, some number of attendance has been done, right? Like out of 30 it is 25, okay, 23, or like 12, 15, okay, 10, 12, okay, and this is what, suppose he had 10, okay, and then he passed, he passed, he also passed, he fails, right? And something like this. So just suppose he also fails, he also fails, he passed. Okay, so some number of guys, how many pass are there? 1, 2, 3. That's fine. So some number of persons pass and fail. Now I have to make a prediction for a new guy. Okay, he had attended a total number of class, suppose 7. Okay, and completed a total number of total number of assignment 7 and attended 15 classes. So will he pass or fail? Okay, so how can we do? Obviously we can use over a logistic regression. For pass it can be 1, for fail it can be 0, right? That we can do, but we will not use that part. We'll use what? We will use this decision tree classifier. Okay, so what decision tree classifier will do? It will collect all the data over here. Okay, all the data will be collected. Now it will start dividing the things into subparts. Okay, it will start dividing the things into subparts like this. Okay, one by one division will be there, correct? So division will be there on the basis of certain kind of a condition. Okay, so what condition we can consider? The condition can be assignment or attendance, anything, right? So suppose I am considering attendance condition. Okay, so attendance I am considering as greater than 15. Okay, greater than or equal to 15, right? So over here it is true and over here it is false, correct? So one thing is clear. Please mute yourself. Someone mic is not muted. Please just check and mute yourself, right? Okay, so it is what? True and it is false, right? So that means what? All the true persons will come in this direction. Okay, attendance is greater than equal to 15. That means what? These person, this is what? This will be there, greater than 15. This will be there, and this person will be there. 1, 2, 3, right? So that means 2 pass and 1 fail is there. Okay, and on the other direction, okay, it's more than 15. This will be there. This, that means pass, fail, fail, pass, right? Pass, fail, fail, pass. Okay, these many guys are there, right? So that means what? You are having these many things, these many information that we are having, correct? So if we are having this information, then it is called subsets, but these are not pure subsets. What is pure subset? A pure subset is a subset which is having just one type of data. So one thing is clear, just like logistic regression, in the logistic regression we were tuning the value of b0 and b1, okay, to get a picture perfect condition. Okay, but over here we have to tune these things. Okay, we have to tune this thing to get a minimum possible error. And who will tell me that what is the error over here? So just let me tell you how to find out the okay, let me tell you how we can figure out the error actually. Okay, let's see. So over here something is calculated that is known as Gini index. Okay, what is Gini index actually? It is very simple, probability of pass multiplied by 1 minus probability of pass. Okay, so that will be equal to what? Probability of pass is what over here? 2 upon 3 multiplied by 1 minus 2 upon 3, that is 1 upon 3, that will be equal to what? 0.6, right? Multiplied by 0.3 is equal to what? 0.18. It is not 0, it represents that it is not a pure subset. Okay, if this is 0, it will represent a pure subset. Okay, same thing for the next case. This will be equal to what? Both are 2, that means it will be ultimately 1 by 2 multiplied by 1 by 2, that is 0.5 multiplied by 0.5, it will be around 0.25, that is also not 0. Correct, that means your algorithm will do what? Will either tune it. Okay, it will tune this particular thing to get a minimum possible Gini index, it will again tune it. Okay, or it can consider the other part things also, like suppose attendance considered, attendance is being checked on all the possible division parameter, like it used more than 10, more than 5, more than 7, everything is checked. Okay, and thereafter it is checking assignments, so it will continuously check all the possible conditions, all possible conditions will be checked over here. Okay, and it will proceed with minimum Gini index, either 0 Gini index or minimum Gini index. Okay, it will proceed with what? Minimum Gini index. That means from 15 it may use something else, like it may use like greater than 20 to greater than 20. If it will use, then what will happen? Obviously it will get a pure subset. Okay, greater than 20 if it will use, then these two will be there only, right? Right, only these two will be there. Suppose over here I am using greater than 20, attendance greater than 20, then what happen? This fail guy will just move out from here, right? Because he's having attendance 15, right? So he will come over this particular thing. Correct. Now if you calculate the Gini index, what will happen? Okay, what will happen? Probability of pass, it is what? 2 upon 2, that is 1. 1 multiplied by 1 minus 1, that will be equal to 0. Okay, 0 means what? It's a pure subset. Okay, so it will just adopt this pure subset. It will calculate for the next one also. Okay, so next one it will be what? Probability of pass, probability of fail also you can consider. It is not that only pass, equation will remain same. For fail, what will happen? 3 upon 5 multiplied by 1 minus 3 upon 5, that is 2 upon 5. Okay, just calculate it, what will be there? 0.6 multiplied by 0.4, 0.24, that means it decreases. It decreases means that means algorithm will figure out that it is going in a correct direction. Okay, ultimately it needs to decrease the Gini index, so it decreases from 0.25 to 0.24. Correct. So what will happen next? It will divide it again. Which one? It may change this thing also. In place of attendance it may pick assignment. I'm not saying that only attendance can be used. In place of attendance it may consider assignment as well. Okay, but if I change assignment over here, there's so many hodgepodge can be there, so I'm just moving ahead. Okay, so now it will divide again. So for this time division, only this much data is left. Correct, this much data is left, isn't it? The upper part is already done. Oh, okay, this much is left. Okay, now again some condition will be defined. Okay, what condition can be defined? Any condition can be defined over here. It can be assignment, it can be attendance, anything, right? So what we can define over here? We can define like this: attendance or assignment, or you can say attendance only. Should I define assignment? Okay, let me define assignment. Assignment greater than 9. Okay, assignment greater than 9, right? So if assignment greater than 9, then this guy will come over here. Okay, who? This 3 guy. No, this assignment greater than 9. This fail guy, this fail person, he's having assignment greater than 9, and this is also having assignment greater than 9. Okay, rest all are assignment less than 9. Right. So this 3 person will come over here. Fail. Sorry, this pass. This pass. Okay, and this also pass. No, this one is fail, right? This one is fail, and last one is pass, right? So that means now it is a pure subset. One more pure subset it got. Okay, again the last one is remaining. Okay, again it will try for this one also to get it into a minimum or 0 level. Okay, if it succeeds, well and good. If it didn't, then it will just stick to the minimum possible point. Okay, now for the last one, what will happen? Again some changes will be made. Okay, so in the last thing we are having these many things. 1, 2, 3. Okay, so these things we are having, right? So what it can do, can it do some kind of a things to make it done? Yeah, again it can use greater than 8, then further one more division will be required. Like it will divide one more, then again it will divide one more. So ultimately the concept is what? This is just a kind of a random data that I use. Okay, so ultimately the concept is what? Your decision tree classifier will tune these values. Okay, it will tune these values. It will consider different values over here. Okay, different features values and different conditions to divide the data. Okay, and it will try to reach this condition. Gene index is 0. Okay, if it is not getting into the 0 location or in a 0 value, it will try for the minimum possible value. Okay, and whenever the minimum possible value achieved, it will stick to that particular thing. Okay, so is it clear like how the decision tree classifier works? Please let me know. I am hoping it's clear. If it is not clear, please do let me know. Okay, I am hoping it's clear for all of you, right? So let's move for the next thing. Okay, so these are the two algorithms that we had seen. Okay, logistic decision tree classifier. Then we are also having an algorithm called C, that is called KNN, K-neighbors classifier. Okay, K-neighbors classifier. Okay, how it works? It works very interesting way actually, right? It uses the concept of neighbors. Okay, neighbors means what? Just consider a case. Just a minute. Just consider a case where you are sitting somewhere over here, right? Suppose you are sitting somewhere over here. Okay, somewhere over here, right? Now what you have to do, you have to like you have to decide like you want to go outside, right? Then you have to decide like will you go outside or will you not go outside? Okay, for any kind of outing, for any kind of movie or something else. Then what will you do? Now you are going to consider your friends, but the nearest friends. So how will you consider? Suppose these are the friends you are having, okay, around your home. Okay, these are different friends. 10 friends you are having, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 friends you are having. So what will you do? What are you doing? You just start measuring their distances. Okay, you measured their distances. You means in the mind only you thought like, okay, this person, this A is at some distance from D1. Okay, this B is at a distance from me D2. Okay. This is a C, he is at a distance of D3. Okay, he is at a distance of D4. He is at a distance of D5. He is at a distance of D6. He is at a distance of D7. He is at a distance of D8. Okay, he is at a distance of D9, and finally he is at a distance of D10. Okay, so A, B, C, D, E, F, G, H, I, J. Okay, so these many guys are there, right? Now what are you doing? You just start calculating the minimum one. Who are the minimum persons, right? Who are at a minimum distance? So you figured out this person, this person, these persons, this person, and these are the your closest one. Okay. So A, B, C, D, and F are the closest one. These 5 persons are the closest one, 5 nearest, right? So A said, okay, he will go. B said, okay, he will also go. C said he will not go. D said he will not go. But F said he will go. Okay. So their labels are at 11001. So majority is saying major, like like out of 5, 3 is saying they will go. So you say that okay, I will go with them. Okay. You will also say that I will also go. Okay. If majority will say no, you say no, then I will not go. Okay, so it is your K-NIN algorithm. That means K-NIN algorithm basically do what? It do all the calculation. Unlike your decision tree classifier and logistic regression, in the logistic regression or in kind of a decision tree classifier, okay, all the calculations are basically done. Okay, all the calculations are basically done at the what? At the what that is known as at the learning stage. Okay, at the learning stage, all the calculations are basically done. Okay, but in case of KNN, all the calculations will be done at the prediction stage. Whenever you are predicting the feature of the input value, the feature of unknown value, because these are also having a feature. Suppose this is having a feature 3 5, this is having a feature 2 6. Okay, so but these are having features as well as these are having labels. Okay, they are not alone. Okay, they are having features as well as they are having labels like this. Okay, but this one, this red color point is only having feature because this is a new entity. Okay, it is unknown to the world. Okay, he came all of a sudden and he wants his label. So what he will do? He will start calculating a distance from all the existing points. Okay, like 2 minus whatever the feature it is having. It must have feature like 1 cross 3. So 2 minus 1 whole square plus, okay, 2 minus 1 whole square plus 6 minus 3 whole square. Correct. Okay, 3 minus 1 whole square plus 5 minus 3 whole square. Better? So this is how you will calculate the distances. Okay, so if the distances means how many distances? Distances from all the data points. It means what? Suppose you are having 10,000 samples with 10,000 labels, right? And this is an unknown point. So this unknown point will calculate 10,000 distances. Out of 10,000 distances, it will consider the 5 nearest one. Okay, and out of 5, what it will happen? The majority will be considered for the prediction, that 1 or 0. It is how your KNN model works. Okay, K neighbors classifier or K nearest neighbor, any name you can give. Okay, both are same. Am I clear? Am I clear with this particular thing?
Yes, sir.
Okay, that's great. So okay, 3 algorithms we had gone through. Now what we will do, we will start we focus over the coding something because some practicals would also be there. Okay, so we'll start doing the coding for it. Correct, like for the coding we'll consider some data. So it is what? Day2 classification. Okay, so we need to use some data values and all. So what data we can use? There are a lot of data are there, right? So we can use some data just a minute, from sklearn, right? sklearn already having some data value. Oh, sklearn dot data sets. Okay, sklearn dot data sets, right? Now what we are having, there are certain data sets over here. Okay, for classification and for the regression. Okay, for classification, like this is a iris data. Okay, it is iris data. It is a diabetes data. For regression, it is digit data. For for what? Classification. Okay, this is a wine data for classification, right? So this is a breast cancer data again for the classification, right? So which data should I consider? Okay, let me consider this wine data. Okay, or okay, this data, because this is a 2 categorical. Okay, it will be easy to understand. Okay, so let me consider this breast cancer data, right? So for classification, right? So how I have to use it is written over there. I have to pick this thing like this. Okay, I'll copy and I will paste it over here. Okay, the way they are telling, I'm using like that, right? So data will be imported. I can use my own data also. I'll let you know how can I use my own data also, don't worry. Why it is taking time to execute? So it is what? It is a data, right? So in this data, what are we having? Okay, this is a data you can see. In this data, you can see we are having this thing in the curly braces. Okay, these are data values. So curly braces means what? This is data in the form of dictionaries, right? So dictionary means what? It must have keys, right? So just use data dot keys. Okay, so if I use data dot keys, okay, this is a Python dictionary actually. So these are the keys. Okay, keys means what? I can pick the data values like that, right? Data. Okay, let me use something else over here. DF, because there is already a key data, right? So that will not look good. DF. So these are the keys, right? That means if I want to access any data value, I can access using the keys, right? So data. Okay, so these are the features we are having. Okay, these are the features. What these features are representing? These features are representing actually some feature names. Okay, so DF feature names, right? So if I'm picking it, so these are the feature names. Feature names means what? The these are representing what? The features of tumors. Okay, feature of tumor, so that a tumor can be predicted. Okay, these are what? These are the feature of tumors. Different feature of tumors that you can see over here. Okay, so that this can be predicted. Okay, tumors can be predicted, right? So these features are basically represented. Okay, so how many features are there? I guess total 30 features are there. Okay, if you calculate it, total 30 features are present, right? So we are having around 30 features, and those features are represented in the data. Okay, you can see from here to here it will be 30 features. Okay, from here to here, how many features are there? Total 30 features are there. Correct. 1 2 3 4 5 6 7 8. That means 30 features we are having, and these 30 features are represented by those 30 features, and then these 30 features are representing labels. What labels are they representing? They are representing the labels like this: DF, target names. Okay, it is representing these features: malignant and benign. Okay, that means there are two types of tumor: malignant and benign, represented by these 30 features. Okay, each sample, how many samples are there? That you can see like this. Just put this data into X. If you are putting it into X, you will get the sample size. If you are putting it into X, you will get what? X dot save. 569 cross 30. Okay, that means there are total 569 samples we are having. And how many features we are having? Samples we are having 569. And how many features we are having? 30 features. Okay, these 30 features are representing what? Labels. How many labels? Labels are present over here. Target, representing 0 and 1. Okay, 0 is for malignant and 1 is for benign, right? So you can put it into Y, and we have to develop a model for that, right? So obviously it is going to be a classification based model. Okay, it is going to be what? It is going to be a classification based model. Correct. So if it is a classification based model, then what we have to do? We have to call the algorithm first, right? Data is defined in X and Y, so call the algorithm from sklearn dot linear model import logistic regression. Okay, and then L model is equal to better. So this is a one line code. We will call the algorithm. Okay, even we can create this algorithm also mathematic, but again as of now, if I'll create, it will take around almost more than 2 hours of time to just create algorithm. That also we can create, but as of now we are just knowing, trying to learn how we can implement it. Okay, thereafter L model to train. Okay, train your model. Okay, so for training your model, what we can do, L model dot fit x comma y. Okay, if you fit it, what will you get? Your model get trained better. So once your model get trained, what we can do, we can calculate the accuracy and all, right? So L model dot score or predict. Okay, so you can make the predictions over x, right? This is a prediction over x. Okay, so just store this prediction over x in y pred. This is the predicted value, correct? That means we are having now two things. L model, that is your logistic regression, dot fit model is trained, predicted prediction is done, y pred. That means this y pred can be compared with actual value, that is y. Okay, when it will be compared, sometimes both will be same, sometimes both will be different. Okay, so when both are same, prediction are correct. When it is correct, we can calculate. I told you in last class, whenever there is true, we can calculate using sum. So when we calculated, we figured out total 539. Divide by total value. Total value is what? Length of x. Okay, this is your accuracy, 94%. Okay, 94% is the accuracy that we are getting, right? So we have to repeat this process for multiple algorithm as well as we'll see about the training and testing thing, and as well as we'll see about the confusion matrix and other things as well. Okay, so before that, I want to take a small break so that I can have a little water, and then we'll again proceed. Shall we proceed by 4:10?
Yes, sir. Yes, sir. No problem.
Yeah, so
Please.
till then, if you want to reach up to this point, I'm sharing the code with you.
Okay. Okay.
Yeah, thank you, sir. Okay, that's great. Okay, so let's move ahead. Try to understand the things. Okay, so what we did till now, we had voice is not audible. Yeah, I guess now am I audible, I guess, right? Okay, so just see over here what we did. We had just trained our model and we had calculated the accuracy, but this accuracy, should we trust? No. Okay, because this is accuracy over the same data on which the model is trained. There is one more way through which you can calculate the accuracy. That means how many times the prediction is correct. Okay, that is what L model dot score. Score is what? Score is your x comma y, correct? So same thing you're getting, so you can get the accuracy like this. But this is not something that we should trust. Okay, what we should do, we should train the model in two different ways. That means there is no training and testing set. Okay, that means over here the data should be divided into two parts. Okay, for validating it, right? That is training and testing set. So divide data into training and testing sets, right? So when you divide data into training and testing set, then what will you get? Let's see. From sklearn dot model selection import train test split, right? Then x train, x test, just wait a minute. Okay, x train, x test, y train, y test equal to what? X comma y, correct? And then L model. Okay, and then x train comma y train. Great. So this is what we are having. Okay, so model is trained now. right? X10, X-test, Y10, Y-test, right? It is your training set. Now calculate the accuracy. Okay, so for accuracy, this is what I will remove now. Okay, I'll use a score only, right? That will be better choice. Okay, this is not required, right? So now we'll calculate the accuracy. Print L model dot score X train, comma Y train. Okay, this is your training accuracy, right? It is your training accuracy. Means accuracy on the same data which is used for the training, isn't it? And this is what your testing accuracy. Accuracy on the data which is used for testing. Okay, so there are two accuracy we have calculated, 95, 93%. Both are very close to each other, then we can trust it. Then we can say that my model is not overfitted, it is well-trained model, and my accuracy is also coming very nicely. It is, that means algorithm is working very good over here. Okay. Now, apart from this, there are certain more things that you have to take care over here. Okay, what are those things? Okay, whenever you are creating any model, there is one way that through which we do the evaluation, that is known as through confusion matrix. Okay, so let me do it. Thereafter, I'll explain what is confusion matrix. That is a evaluation process of a model, right? So, for confusion matrix, what we need, first of all, make the prediction. Y test prediction. Y test prediction is equal to what? L model dot predict. Okay, dot predict. That means we are making a predictions over X test. Why X test? Because X test is unknown to the model. Okay, because your L model is knowing only about two things. Okay, because the training has been made on X train and Y train. So if training has been made on X train and Y train, that means your model is, if it is knowing something, that is knowing about X train and corresponding Y train value. It is knowing nothing about this thing. Okay, it is making a prediction over X test. Okay, and then comparing a prediction with it and getting 93% accurate result. Now again I am doing the same prediction. Okay, so prediction is made, and thereafter what I will do, I will use from sklearn dot matrices import confusion matrix, right? And then I will call confusion matrix. It is very important thing, right? You should know it, right? Y test comma YT. Many of you might be knowing this thing also. So if you are knowing it, it's very good. Otherwise, we should know it, right? So why it is important, I will tell you now. So it is what that you are getting, confusion matrix. Okay, so confusion matrix is telling us what? In so many sensitive case, okay, in the sensitive cases or in the imbalanced set of data, okay, it helps us a lot to evaluate our model, okay, for the evaluation purpose. Okay, for example, just consider a case that you trained a model by any chance, okay, with for a prediction of A and B. Okay, the data that you use for training, in the data, number of sample of A is suppose 100. Okay, number of sample of B is suppose just 10. Correct. Thereafter, what you did, you just trained it. Okay, and then in the testing, you are having a data, for example, number of sample, as suppose number of sample for the testing you are having is 10. Okay, and number of sample for B you are having, suppose, is something like 3 or 2. Okay, like this. Correct. Then there is a heavy irregularity, right? Now once you trained your model, right, and then you try to predict. When you try to predict, what happened? Total, you can say, out of 10, all 10s are get predicted correctly, but these two are also predicted as A. Okay, these 10 are getting predicted as A, these are also getting predicted as A. So in this case, what is happening? Your model is highly accurate for a specific set of data. Okay, but it is not accurate for the another set of data. But accuracy, overall accuracy will be very high, isn't it? Overall accuracy will be what? Will be very high, because out of 12, 10 predictions are correct. So obviously overall accuracy will be very high, but if you go into the depth, you will figure out that your model is unable to predict B. Okay, why? Because for the B, it got very less data. Okay, so it is what? It is a scenario that we face in the imbalanced data sets. Okay, so that's why confusion matrix we should always use for evaluation. Okay, how it basically helps us? Let's see. It helps us like this. first of all, we are having these things 45.8. Okay, so what it represent? It represent first of all predicted 0. Okay, predicted 1. Okay, it is what actual 0 and it is what actual 1, right? That means over here if I write 45, that means for the 45 times prediction and actual value both are 0, that means correct prediction. For the 88 times the prediction and actual value both are 1, that is correct one. Okay, for the 8 times, okay, prediction is 1 but actual value is 0, and for the 2 times prediction is 0 but actual value is 1. Okay, that means for the 8 times what happened, it was 2 tumors, magnetite benzene. Okay, it was predicted benzene. Okay, but it is what? It is actually malignant, right? And for the 2 times it was predicted malignant, but it was actually benzene. Okay, so these kind of error can create a quite sensitive cases in case of medical. Okay, in case of medical predictions, okay, these can create a kind of a life or death kind of a thing. Okay, like suppose someone is suffering from a disease, okay, and the test didn't recognize it. Okay, then what will happen? Then it will be a problem, like it will be a problem of life for him. Okay, because the test didn't recognize his disease, right? So this kind of error can be a big problem in case of medical sets of data. Okay, in case of medical sets of data, this can be a huge problem, right? So basically it is that is how it needs to be evaluated for solving out or for decreasing or dimining this kind of a error problem, right? So let's see how we have to work upon it. Correct. Look here, so we are having what? We are having this thing. Okay, that means anyhow this particular algorithm is working quite good. Okay, here the values are not quite big. Okay, and other thing that we should know in this confusion matrix is the name. Okay, what is the name of these positions? Look here, predicted 0, predicted 1. Okay, let me write in black color. Predicted 1, predicted 0, actual 0, actual 1. Okay, first of all just figure out the position where the predictions are correct. These are the positions where predictions are correct, so these positions will be named as true. We call these things as a true. Okay, and what are the positions where the predictions are wrong? These are the positions where predictions are wrong, so it will be called as false. Correct. Thereafter this is called as what? You can say it will be called as what? Over here the predictions, if it is true, then what we should call it? We have to call this thing as a true positive or true negative. Okay, so when we will call it true positive and when we will call it true negative, or false positive and false negative. Okay, so first of all let me tell you what exactly happens if you are using this particular thing. So this is getting false. Okay, this will be called as what? False. And false because of what? One is what? Positive, so it will be called as false positive. Okay, and this will be called as false, and false because of what? This 0, that's why it is called as false negative. Okay, it will be called as false negative. Correct. And it will be called as true positive. Yeah, true positive, and this will be called as no, I'm doing some mistake. I guess I'm doing some mistake. I guess true positive should be on the top, will be called as the true positive most probably. I'm doing a mistake over here. Just a minute, I have to just confirm it, because according to my concept, the formula that I am going to apply, that is conflicting over here. Yeah, right, it was, no, I was not doing actually mistake, it was correct. So it was what? True positive. Okay, why positive? Because it is true because of the positive value. I was I was confused a bit. And this will be called as true negative. Okay, it will be called as true negative. Why? Because it is true because of negative value, that is 0. 0 is considered a negative value. So these names had been given over here. Okay, now the question is why these names had been given over here. Why I had given this true negative, true positive, and false negative, false positive? These names had been given to calculate two important figure. Okay, these names had been given to calculate two important figure during the process of evaluation. And what are those two important figures? Those two important figures are true positive rate and false positive rate. What? Those two important figures are true positive rate and the false positive rate. Correct. Now, how to calculate true positive rate and the false positive rate? Let me tell you. To calculate true positive rate, what we do like this thing. TPR, that is true positive rate, is equal to true positives upon, okay, true positives upon true positive plus false negative. Okay, true positive upon true positive plus false negative. Okay, this is what. Okay, that means if you calculate it, what will you get? It is 88 upon 88 plus what is false negative? This one, 2. Okay, that is what we are having. Okay, true positive rate. Now, where to use true positive rate? Next, we have to calculate false positive rate. What is false positive rate? False positive rate will be equal to false positive upon, it will be equal to false positive upon false positive upon false positive plus true false positive upon false positive plus what we have to do? Anyone knows about it? True negative, right? Same thing. Okay, so false positive and false positive plus false positive plus 2 negative. So what is false positive? False positive is this value 8. 8 upon 8 plus true negative is 45. Correct. So these two things are calculated. Now question is, why are we calculating these two things? Okay, true positive rate and false positive rate. Why we are calculating these two things? To draw a curve that is known as ROC AUC curve. Okay, why we are calculating it? To draw a curve that is known as ROC AUC curve. So what it means actually? Okay, what it means? Okay, so how can I explain it? Just a minute. Okay, I will explain like this. Just suppose there is a curve over here. Okay, on this curve, if I am making TPR over here, TPR, suppose I am giving over here, okay, and over here I am getting FPR. Okay, so what will happen? I will keep tuning the parameter. Okay, I want the best possible thing. So how can I get the best possible thing? By tuning parameter. So as I'm tuning the parameter, my true positive and false positive rates are continuously changing. Okay, my true positive and false positive rate are continuously changing. What is the best possible true positive rate? It is 1. Okay, when it will be 1? When this false negative will get into 0. Okay, when this will be 0, then it will be 1. Okay, that means this true positive rate needs to be as high as possible. Okay, and false positive rate needs to be as low as possible, because this should be low. Okay, this should be low, right? And when it will be low, obviously, the value will be more closer to 0. Value will be more closer to 0, right? So false positive rate should be as closer to 0 as much possible, and true positive rate should be as higher as possible. So this is a best condition will be like this. Okay, so basically I am changing continuously the tuning the parameter. Okay, so tuning the parameter, with the tune of parameter, I am getting different, I am getting a curve like this, for example, right? This is what the curve I am getting. Correct? True positive rate versus false positive rate. Okay, so what actually happening over here? So many curves is drawn. Sorry. Okay, so I hope you understood it. Otherwise, okay, this is a curve drawn. So this curve is known as ROC curve, and the area under this curve is known as AUC, area under curve. Correct? And the best situation is known as over this one. Okay, that means at this one we are getting a best possible situation. Okay, because this is a maximum ROC AUC. That means this is a maximum TPR with minimum FPR, maximum TPR with maximum ABR. Okay, so basically how it is used for evaluation. Suppose you use logistic regression. You got something like this. Then you use decision tree classifier, okay, and you are getting something else, okay, and then you are using some other algorithm and you are getting something else, okay. So the curve which is having the maximum area under it will be considered as the best algorithm. That's why area under curve is basically compared. Okay, the curve which is having a maximum area under it will be called as best possible algorithm for that data. Okay, so this AUC ROC curve is not used for kind of improving something. It is used for comparing. Okay, comparing multiple algorithms so that you can decide which algorithm is best for me. Correct, and this is how TPR and FPR is calculated, and it is used for ROC AUC curve. So just let me know if any doubts over here related to confusion matrix, TPR, FPR, ROC, AUC, anything. The full form of ROC is something recursive object component that you can just see. Like I just missed what is your full form. Some full form is there, so you can just figure out. I am just trying to explain the meaning of it. Am I clear with it? Any doubt related to it? Please do let me know. You want me to explain again? Actually, I can't access chat, so if you can speak out, it will be better.
Yes, sir. Yes, sir. One participant say yes, sir.
Okay, so you want me to explain this thing again?
No, I think. Yes, he said yes. Yes.
Okay, fine.
Yeah.
I'll explain. Okay, fine. So let's see. We'll see this thing again. Actually it's a very important thing. So that's why, if your things are not clear, you should ask me to repeat it again, right? Okay, so basically why we use it, what are the values? First of all, let me pick the values. 45, 8, confusion matrix values. (45, 8, 2 and 88), right? Okay, 45, 8, 2 and 88, right? So this is what, okay, this is what predicted 0. This is what predicted 1. Okay, this is what predicted 0. This is what predicted 1. There are so many cases here. It is quite balanced, but when you work with some other data, there you will get some cases there is very imbalanced set of things. Okay, so it is used for figure out the imbalance situation, right? Now that means, suppose there is a prediction happens somewhere like this 45. It is 45 correct predicted. Okay, 8 wrong predicted, and over here suppose 10 correct predicted, sorry, 10 incorrect predicted and 3 correct predicted, right? So if you calculate the complete accuracy for it, the accuracy will always be higher. Okay, because accuracy will be higher because 45 plus 3 is the correct prediction. Okay, 45 plus 3 is the correct prediction, and if you divide it by 45 plus 3 plus 10 plus 8, accuracy will be higher, right? It will be a good accurate model. Okay, much accurate model over here. But again, you can see the another type of, the second type of sample is not getting predicted well. Okay, on majority it is predicting wrong. Okay, for the second sample, the major of the predictions are wrong. Okay, and very less are getting predicted correct. That means your model is favoring one of the sample or one of the category. Okay, your model is favoring one of the category. So this kind of model needs to be avoided. Okay, this is one use of confusion matrix. This is just one use of confusion matrix to figure out any imbalance prediction. Okay, second use known as ROC AUC curve. Okay, ROC AUC curve is used for kind of a comparing multiple algorithms. So how it is calculated? It is a curve between TPR versus FPR. Okay, TPR versus FPR. What is TPR? TPR is true positive rate. What is true positive rate? It is TP upon TP plus what? FN. Correct. FPR is what? FP upon FP plus TN. Okay, true negative, right? So if you calculate this value, what will you get? Now just see. First of all, you should know how to read the confusion matrix, right? So to read the confusion matrix, it will be like this. Okay, so here the predictions are correct, so it should be true. Here also prediction is correct, so it should be true. Here it is wrong, so it should be false. Okay, here it is also wrong, so it should be false. Correct. Now it is predicted 1, it is predicted 0, it is predicted sorry, actual 0, it is actual 1, right? So here the it is false because of positive value, so it is false positive, FP. Okay, and it is what, it is also true positive. Okay, because true because of this one. Okay, and it is what, true negative, and it is what, false negative. Correct. So this is what we figure it out. Okay, it is true because of negative value, false because of negative value. Now calculate TPR. What will be the TPR? TP is what? TP over here, this is TP. TP is what? TP is 88. Okay, TP upon 88 plus Fn. What is Fn? Fn, this one, 2. Okay, so for the better performance of the model, what we need? We need this value to be as bigger as possible and this value to be as smaller as possible. Correct. That means what? Your ROC, in the ROC case, the TPR will be the maximum, will go to 1. Correct. FP, what is FP? False positive. What is false positive? This one, 8. 8 upon 8 plus TN. TN is what? 45. Okay, so what I want, if I want my model should be good, that means this should be as low as possible and this should be as high as possible. Okay, that means for this the best possible condition is 1. Okay, for this the best possible condition is 1, and for this the best possible condition is 0. Okay, when it will be 0? When 8 is 0. That means if this is 0, then automatically FPR will be 0, right? So the best possible condition is 0. That means FPR is trying to be as small as possible. Okay, so if any point that is present over here, that can be considered as the best possible point, right? Any point that is present over here will be considered best possible, but generally don't happen. So basically what we want a situation where the maximum area can be covered within this particular thing. Okay, this is a curve that we want. Okay, area under curve. Okay, and this curve is known as ROC curve. Okay, this curve is basically drawn at different threshold value. Different threshold value means what? I told you, in the logistic regression we use what? Threshold value. Okay, suppose here threshold value is kept. Okay, then this is what point we are getting in TPR versus FPR. Okay, threshold value change, TPR versus FPR, this is what we are getting. Okay, again threshold value change. So as it is keep changing, at a particular threshold value we are getting a TPR versus FPR like this. Okay, and after that again it start increasing or decreasing, something like that. Okay, so this is this corner point we consider, or this corner point algorithm considered as a best possible condition. Okay, not over here, not over here. Correct. Correct, and that is known as, and this is known as your ROC curve. Okay, then you are using some other algorithm. Okay, and in that algorithm the curve is drawn like this. Okay, that means obviously this algorithm, this green color algorithm is not good, this one is good. Okay, because it is having more area under curve, because it is more close to the 1. TPR is more close to the 1 and FPR is more close to the 0. Correct, it is good one. Okay, over here also, that means it is used to compare the model accuracy in case of unbalanced set of data. Now is it clear? So if suppose there is an unbalanced set of data, it will not be like that, right? Suppose if there is, you can just calculate. Okay, if there is an unbalanced set of data, suppose here the number of correct prediction is 200. Okay, and like that if it is working, then what will happen? Obviously 200 upon 200 plus the wrong predictions are 200 upon 88. Okay, so obviously it will not be close to 0, it will be close to 1, it will be somewhere here. Okay, that means FPR is not performing well, TPR is performing like, to the TPR, this will be the curve. If this is a curve, that means very less area, right, within this one. That means it is a very poor model. Even accuracy is very high, but still model is very poor because area under curve is very less. Why it is very less? Because for another kind of, there are two categories. For one category it is working good, for the another category it is not working good. Am I clear?
Yes, sir. Yes, sir.
Okay. Okay, so let's move ahead. Okay, fine. Okay, so now we have to do it. So how can we do it? For doing it, there are certain libraries. I will just let you know how can we draw it quickly. There are certain libraries actually. Just give me 1 minute of time. Okay, so what we can do. Okay, I will just write over here. ROC AUC Pro. Okay, so what we can do from sklearn dot matrix import, what we can import ROC underscore curve. Okay, and then from sklearn dot matrix import ROC AUC score. Okay, one more. Oh, what happened? Matrix. Okay, and for plotting also, let me import from sklearn. 1 minute, just 1 minute. God. Give me 1 minute. From sklearn dot no, import matplotlib dot pipe plt as plt. Okay, so this is for the plotting. Okay, the upper two libraries are for the calculations. Okay, now what we will do, we have to calculate. Okay, so what we can calculate the ROC AUC score. Okay, so for calculating the ROC AUC score, we need a predicted value. So predicted value is whitest spread. So what we will do, we'll calculate AUC score is equal to, this is area under curve actually, ROC AUC score. Okay, and I have to pass two value over here. What? Test, y test, comma, y test spread. Correct. So this is a AUC score. Okay, what is the AUC score? Let us see. That is area under curve. It should be as big as possible. Okay, 91, right? With compared to any other algorithm, it should be as big as possible, right? Okay, and then we have to do what the curve also have to do, draw, right? So for the curve, we need false positive rate and true positive rate. So FPR, TPR. Okay, and it gives one more value, that is that we'll just use as it is. Will not use it. Okay, and is equal to ROC underscore curve. Okay, what test? Sorry, y test, comma, y test spread. Right. So FPR and TPR will be calculated, and once FPR and TPR will be calculated, what we can do, we can plot it. Okay, PLT dot plot. Okay, on the x-axis, what I can pass, it is FPR, right? False positive rate. On the y-axis, what I can pass, TPR, that is true positive rate, right? Okay, and line style, we can pass line style. Line style is equal to any style we can pass over here. Okay, and colors and all those things also, you can also give color is equal to red. Okay, PLT dot show. Okay, and one more thing, let me give plt dot x label false positive rate okay, and plt dot y level true positive rate. Okay. So it is a graph that we are getting much better, right? So it is a graph that we are getting for a logistic regression. Okay, the same way we used to do the same thing for the different algorithms, and we draw the graph one above the other, and then we compare, and then we decide which algorithm is working better for me, right? For example, if I have to do the same thing for what, for kind of that one thing, what that is known as, if I will use something else, then just a minute. It is not, if I not give, then also it will draw simple line, it is drawing. Okay, it's, I was supposed, okay, fine, anyway. So now let us do the same thing for decision tree classifier, okay, or knn, right? So from sklearn dot tree import DSCI decision tree classifier. Okay, D model is equal to decision tree classifier, right? Okay, and then D model dot fit x train comma y train, correct? And then predict our x test. Okay, so y test I will use over here, y test spread. Okay, y test spread I will use, but name should be changed. For decision tree I'm using tree over here. Okay, y test spread tree is equal to what? D model dot predict, okay, x test. Okay, so x test will be predicted over here. Once it will be predicted, then what I can do, I can calculate these things. Okay, TPR versus FPR. So I will just copy this and I will paste it over here. Okay, now TPR FPR tree I will use. Okay, and TPR tree to differentiate. Okay, ROC curve, y test and y test spread tree. Correct, it is done. As well as I need the things, this one AUC score. So AUC score I will calculate later on. First of all, do this part. Okay, done. Okay, and then again from sklearn dot what was that, neighbors import k neighbors classifier. K model is equal to k neighbor classifier. K model dot fit x train comma y train, right? And then what we can do, we can just use this thing. Just will change that part, y pred kn. Okay, y test much better. So TPR FPR both have been calculated for this one also, right? Now what we will do, we will just plot this thing for comparing all of these three, correct? Okay, oh yeah, like I just made a mistake, it should be K model, right? K model dot predict text set k model dot fit k model and d model dot fit d model, right? D model k model, right? Now it is correct. Better. Okay, and then what we will do, we will just plot it for 3 times. Okay, first it is FPR versus TPR, second it is FPR tree versus right, third it is this one. Okay, first red, then green, okay, then blue. Okay, so it shows the green one is the best one. Okay, which one is the green one? Tree. Okay, that means decision tree. For decision tree it is showing the maximum things. Okay, after green the red one is better and then the blue one is better. Correct. So we can calculate the AUC score as well for all these three. Okay, so to calculate the AUC score, what I will do, I will just pick up the things. Okay, ROC AUC score, this is for the normal one. Okay, so AUC score, it is for what? It is for logistic. Okay, it is for what? It is for tree, and it is for what? It is for KNN. Correct. So whitest spread, and whitest spread for, but it is different for everyone, right? It is whitest spread tree and whitest spread KNN, right? Yeah, whitest spread tree and whitest spread KNN. So this is for whitest spread tree, and this is for whitest spread KNN. Okay, calculated, right? Now we can print these values. Print AUC score log. Oh, what is happening? AUC score tree and AUC score KNN. Okay, so what are you getting? We're getting a maximum AUC for tree. That means for this particular data, decision tree is working best. Okay, you have to calculate the score and all that. Also, you can calculate print. First of all was L model dot score. Correct. X test, comma Y test. Okay, this was the first model. Second was the D model, and third was the K model. So a score is best also for D model. Okay, for the decision tree, a score is also best. This one AUC score is also best. Okay, and the area under curve by plotting also, that is also showing a better situation for the this one. Okay, for what? For decision tree. So decision tree will be the preferred model for this if we compare all one. Okay, now for making the predictions, what we have to do, you have to just call it. For example, just pick any sample from X test. X test is having so many samples. Correct. You can pick any sample from here, like sample number 6th. Okay, and I have to make the predictions over it. So these are different 30 features. Like user, you can take the 30 features from the user. So over here, there are 30 features I'm picking up from the X test. So what I will do, I will use over here D model dot predict. I'm using, I can use any model, but since D model is giving me the best possible accuracy over testing data, correct? So that's why D model dot predict X test 6. Okay, what I'm getting a SAPE error because the for training 2-dimension data is used, and I'm passing single sample. The single sample is in single dimension. So just pass within a bracket. Okay. So it is array 0. Array 0 is representing what? Array 0 is representing your first type of, it is array 0 is representing basically the first type of tumor, right? Actual value is also 0. Okay, I want the actual value, the tumor name. So what I can do, there is something called labels, or you can say um, class, predicted class. Okay, predicted class we can call by using df target names. Okay, df target names, then see prediction class. What is prediction class? Prediction class is an array of malignant and benign. It is giving us the index 0. If index 0 will be passed through this particular thing, we will get the actual label. What I mean, I can pass p class. I will get the actual predicted value malignant, and I can put it over print. Okay, so actual predicted value I am getting for a particular sample AICTE-ISTE, correct? If I have to predict the multiple value, I can predict the multiple value like that only, right? What I can do in that case, I can just pass the multiple values like this: AICTE-6, comma AICTE 56 or 53. Okay, so first one is compared as a malignant and second one is benign. 53 is benign. Okay, you can compare, you can verify with the actual label, that is white test 56. It is also okay. Over here the prediction is wrong. It is showing 1 0. Oh, sorry, 53, right? So I'm sorry. 1, right? You can see the prediction is right. Correct. I have shared this data with you, shared this complete file with you. Just go through it and try to apply the same logic for different data sets. Okay. So what we covered in this session, we covered about the classification problem. What is classification actually? What are the different algorithms of classification? 3 algorithms I covered. Okay. In that 3 algorithms, though all those 3 algorithms we have applied as well. Okay, using the sklearn, and the one of the most important thing that is used for comparison, that is ROC AUC, that also we had covered, and we understood about what the true positive rate and the false positive rate, and we had seen how true positive rate and false positive rate is used for ROC curve. What is ROC curve? Basically, I will tell you, the full form is something recursive objective curve, something like that. ROC curve, if I call it, the name is receiver operating characteristic curve, right? Receiver operating, that full form, if you want to know, you want to note down, you can note it down. AUC stands for area under curve, right? So as big the area, the better the model. That is the representation. Okay, so you can see, if you will you want to verify the kind of that thing also, you will see the better thing. Like for example, if you want to verify confusion matrix, okay, for what? For this thing, for D model, for K model and D model, for both you can apply UI test, comma Y test spread tree. Okay, this is a confusion matrix for decision tree. You can see much better situation. It is a total win-win situation. Only three values are wrong. Okay, rest all predictions are correct. That's why ROC AUC curve shows that kind of jump, right? For KNN, it is not like that. Okay, for KNN here the number of predictions are very wrong. That means they are predicted 0, but they are actually 1. So it is not showing. Means for the second class it was working good, but for the first class it is not working good for KNN. Okay, so KNN is working good in the second class. Okay, for this one you can see it is also, the first class is not getting predicted well, but for the decision tree both the classes are getting predicted very well, and that's why decision tree is used for the prediction of the further things. Am I clear with it? Please just let me know. Thanks a lot, sir.
Yes, sir. Yes, sir.
Okay, how to calculate area? How to calculate area? This is the area actually. Where is the area? This is the area. ROC AUC score. This is the area, right? Yeah. So you can see over here area is maximum. Okay, so this is it for today's session, classification thing. Okay, try with some other data and all. And if you're having any doubts, do let me know your doubts. I'll try to sort it out. Okay, because in classification there are a lot many things I can tell, but these are the important things I just choose to tell you because generally like ROC AUC explanation we don't get easily, means there are so many explanations are there but people don't use it to use, like it is very confusing, like whenever anyone explains I can understand, like many times we usually get confused. Okay, that's why I choose this topic so that it can be clear for all of us. I hope it is clear, right?
Yes, sir.
Okay, that's great. So if it is done, shall we sign off?
Yes, sir. No problem. I hope everyone participant has cleared his problems. Okay.
Right.
Yes. Any participant will have any query, please ask. No problem. I think yes, they are saying yes. No problem. Okay. Thanks, Bipul. Then you have
Thanks a
conducted
lot.
nice session. Very good.
Thanks a lot.
Yeah. You clear all the problems of the all participants. So on the on the behalf of SSBT and Department of ANTC, we thank you. Thank you very much. Okay, then see you, Bipul, tomorrow. No problem.
Okay, see you, sir.
Yeah. Thank
Take
you
care.
all the participants for patience listening. So we will meet you tomorrow at 10:20 sharp. Okay, we will start the session near about 10:20. Okay, the first session will be starting at 10:30 only. Okay, so please join it immediately in the morning. Thank you very much. Okay, I'm giving you feedback link. No problem. Those who have not given attendance, those they can give the attendance over this link. Okay, no problem. Just click it. And in case earlier if you have missed earlier attendance, then no problem. In our log, Webex log, that attendance is preserved. So we will check it. And then after that, you will get everything. Okay, no problem then. You just try to log in and attend the sessions. Okay. Yeah, thank you very much. I hope everyone had given attendance. So should I quit the meeting?